Hello, this is Sumita Gupta. Welcome you all for my lecture TCP/IP layer function in Internet Communication Engineering. Okay, so these are the outlines. First, we will see the difference between OSI and TCP/IP layer model. Then we will learn the TCP/IP model layer wise. This is open system interconnection model versus transmission control protocol of the internet protocol. Okay, in OSI model, there are 7 layers: physical, data link, network, transport, session, presentation, and application layer. But in TCP/IP model, the last 3 layers are combined. So in TCP/IP model, basically there are 5 layers: physical layer, data link layer, network layer, transport layer, and application layer. Okay, again listen carefully. In OSI model, there are 7 layers, but in TCP/IP model, there are 5 layers. Okay, so we will learn today this TCP/IP model layer wise. So before going in detail, first of all, there is link. What is link in this protocol? So see, whenever you want a communication between two computers, computer A and computer B, there are different paths. So in different paths, we have to create a link. So from A to B, there is link 1, link 2, link 3, link 4, link 5, and different routers. Router 1, router 2, router 3, router 4. So from A to from B, there are different links, means 1, 2, 3, 4, 5, 6 links, and 1, 2, 3, 4 routers. Okay. So whatever connection is through different links and routers. Okay. So first of all, physical layer. See, this is computer A and this is computer B. We want to transmit data from computer A to computer B. This indicates white one for source and black one for destination. So it will go from A to router 1 to router 3, router 3 to 4 to A. See here two paths. Either it can follow this path A to R1 to R3 to R4 or B. Otherwise, it can follow the path A to R1 to R2 to R4 to B. Okay. So again, listen carefully. The transmission from computer A to computer B is going through A to router 1 to 3 to 4 to B. So whatever communication is done through node to node A to R1, then R1 to R3. So when connection is established, then a stream of bits are transmitted. Data is transmitted. So data is transmitted by node to node communication. So what is the communication unit? That is node. So data is transmitted node to node. That is the main point. So in physical layer, the communication is between two hops or nodes. That is either computer or router. So main point is the unit of communication is single bit, or we can say node. Okay. So physical layer treats each bit individually. Physical layer treats each bit individually, means one bit will be passed through this to this to this. Okay. So communication is bit, or we can say a node or a hop. Okay. That is your physical layer. Now next layer added, that is your data link layer. Now the word is data. So definitely is a combination of bits, data, or we can say one header is added. D for bits and H for header. So now when header is added, it is called frame. The communication between computer A to computer B happens by the frame. In the last case by the node, but in this case it's a frame. Frame means one header is added in a whole, here. So whatever data is transmitted, in that data one header is added. What is the role of header? Header is added just include the address of source and destination. That is the main point. So what is the communication unit? Now communication unit is frame. Okay. So at this level, communication also between two hops or nodes, means now it is a combination of nodes and the combination of bits. It is called frame. So in the last case, what was happening? In the last case, it was bit by bit. Okay, or we can say node. Now in this case, it is a combination of bits, or we can say frame. So unit of communication is now frame, data link layer. Now next part is network layer. Okay, next part is network layer. Network layer means that definitely networking protocols comes in picture. That is internet protocol. Now, combination of frame is called datagram. Combination of frames are called datagram. So now the datagrams passes through A to R1 to R3 to 4 and B. So now unit of communication is your datagram. Okay. So this is the role of network layer. After network layer is transport layer. Now combination of datagram is called segment. Combination of datagram is called segment. Okay. So now segment passes through computer A to router 1 to router 3 to 4 and B. So now what is we are transmitting? Combination of datagrams. Combination of datagrams called segments. So means segment can be broken into different datagrams. After this, next layer is your application layer. Application layer is the last layer. So in the last layer, many protocols will be there. Okay. In global internet, local internet, many protocols will be there. Electronic mail, file transfer, access in the world wide web. So many facilities will be in application layer. But the main thing is now whole message is transmitting. Means combination of segments. Now the unit of transmission is message. Whole message is transmitting from A to routers to next router to router to computer. Means again listen in short, in physical layer bit by bit transmission. In data link combination of bit that is called frame. In network combination of frame that is called datagram. In transport combination of datagram that is called segment. And application layer combination of segment that is called message. Okay, bit, frame, datagram, segment and message. So in this way you can learn easily your TCP/IP model. Thank you for listening. Keep learning, keep sharing. If you really like it, please like and share. Don't forget to subscribe my channel. God bless.